IP address is Internet Protocol Address. As like our name, as like our postal address, it's an unique address that's used to identify a device in the network, IP networks. So as of now, there are two versions available for IP addresses, that is IPv4 and IPv6. That's IP version 4 and version 6. And there are two types of IP addresses, public IP and private IP. Private IP is nothing but the IP addresses that's used to work within an organization or within a local network. Where a public IP address is the IP address that's used within the internet. The IP addresses can have two portions, that is network portion and the host portion. The network portion describes what's the network the device belongs to, and the host portion describes which exact host among the many hosts. So an IP address is a 32-bit binary bits. So this 32 binary bits have been broken into 4 octets and converted into a decimals. The value of each octet ranges from 0 to 255 in decimal, or all zeros to all 1 in binary format. So this is the decimal format of an IPv4 address. It's a 32 binary bits. It's converted into decimal formats and divided into 4 octets. Each octet value is ranges from 0 to 255. So this is the decimal format, sample format for the IP address. That's 192.68.10.11. So next we'll see about subnet. Subnet is nothing but it's a logical subdivision of an IP network. That's logically we are dividing an IP network, a big network, into many small networks. This is what a subnet. So what are the advantages of the subnet? So there are a lot of advantages in subnetting a network. The primary advantages are it's simplified the management. That's it's very easy to manage the network. If it's a big network, it's very difficult for an administrator to manage. So if we logically split into many small networks, it's very easy for management. As it's easy to manage, it minimizes the broadcast because we have logically divided into many small networks. So the broadcast level also minimized. So as the broadcast is minimized, the performance of the network is good and it's secured when compared to a large IP network. So next thing we are going to discuss about subnet mask. The subnet mask is a 32-bit number that's used to identify which is the network portion and which is the host portion of an IP address. So in general, if we put all the network bits as a 1 and all the host bits as a 0, we can get the subnet mask of the IP address. So the last octet of the IP address is reserved for two specific functions. If the last octet is mentioned as a 0, this indicates the network address of the IP address, and if the last octet is specified as a 255, then this is a broadcast IP address. So these are the 5 classes that's available in the IPv4 addresses. That's class A, class B, class C, class D and class E. Let's discuss in detail. Class A. So the first octet, if the first octet ranges from 1 to 126, it comes under class A. So the IP ranges that's used here is 1.0.0.1 to 126.255.255.255. So it supports 126 networks, and each network supports 16.7 million hosts to have. So the natural subnet mask of class A network is 255.0.0.0. So the first portion as it consists of 4 octet, the first portion of the IP address specify the network address of the device, and the last 3 portions specifies the host ID. So if, for example, if 100.52.35.12 is the IP address, as the first octet is 100, the ranges from 1 to 126 comes under class A. So as it's 100, it's a class A IP address. So in class A IP address, the first portion is a network ID, that's a network portion, and remaining 3 is the host portion. The second thing is class B, in which if the first octet ranges from 128 to 191, it's a class B range. Here the IP ranges are 128.0.0.1 to 191.255.255.255. It supports 16,382 networks, and each network support 65,534 hosts. So the natural subnet mask used in class B is 255.255.0.0. So here the format will be, the first two octets will be network portion, and the second two, that's the last two parts are the host portion. For example, if a IP is 150.10.10.1, the first two, that is 150.10, is a network part that describes about the network the IP belongs to, and the last portion, that's 10.1, it's an host address that describes about the host that belongs to the network 150.10. So the next one is class C. If the first octet ranges from 192 to 223, then it's a class C IP addresses. Here the IP address ranges from 192.0.0.1 to 223.255.255.255. It supports nearly 2 million networks, and each network supports 254 hosts. So the natural subnet mask is 255.255.255.0. So this is the format. That's first 3 octets describes the network portion, and the last portion describes the host address of the network. For example, if IP address is 192.68.10.1, then the first 3 octet, that's 192.16.10, describes the network address, and that one that specifies the last portion describes about the host address of the address. So the fourth class is class D. If the first octet ranges from 224 to 239, then it's class D. Here the ranges are, it's from 224.0.0.1 to 239.255.255.255. These ranges or IPs are reserved for multicasting purposes. So these IPs are not used anywhere. The first 3 classes, that's class A, class B, class C, are used for internet, connecting your device to the internet, whereas class D is used for reserved for multicasting, and class E, that's the range from 240.0.0.1 to 254.255.255.254, is class E, that's used for research and development purpose. That is, class D and class E are reserved IPs. Class D is reserved for multicasting, and class E is reserved for research and development purpose. So here is a private address IP addresses ranges. So these addresses are used to have work within an organization or within a local networks. So this is a /8 network, /12 network, and /16 network. This is 10.0.0.0, which subnet mask is 255.0.0.0, and this is 172 to 16.0.0 till 170 to 31.255.255. Here it's the class E of a private address is 192.168.0.0 to 192.168.255.255. So these IPs are used to work within the local network.